Microcontroller NPTEL course week 3 assignment. So if n denotes the number of clock cycle and t denotes the clock period at which the microprocessor is running, then the duration of execution of loop can be denoted by n into t. Suppose instead of this t, if they are going to give the frequency f, it can be given by n divided by f. So the content of the accumulator after execution of the following instruction will be, so MVI A comma B7. So the accumulator content will be of B7. So this 10111. So this is going to be your B, and then 0117 is 111 is going to be 7. Now ORA is nothing but logical OR operation. So if any one of your content is 1, the output is 1. So here if you are performing the logical OR operation with your accumulator, the same content will be displayed in the accumulator. Next, the carry will be 0. For logical OR operation, the carry will be reset. So carry is 0 here. Now RAL will tell you that rotate the accumulator left through the carry here. So the value of A is this one and accumulator is 0. So I am just moving the accumulator content to the left. So D0 to D1, D1 to D2. So it goes on. So and then what happens from D7 to your carry, then from carry to your D0. So if I perform this way, so 1 1 1 0 1 1 0 will be shifted left, and this 1 is shifted to the carry now. Now the carry bit 0 will be shifted to the D0. So after shifting operations performed, so the value 0 1 1 0 is going to be 6, and then 1 1 1 1 0 is nothing but your E. So your answer is going to be 6E. So now immediate addressing, implicit addressing, register addressing, direct addressing. Immediate addressing means if the content which is to be manipulated is present in your instruction, if it is a part of an instruction, it is said to be immediate addressing. And in implicit addressing is without mentioning about the registers or something else, the mnemonics itself tells you what action to be performed. And registered addressing, both your source and destination will be of registers. And direct addressing, the address where the data is, that will be the part of the instruction, that is called as direct addressing. So here LXI H comma 2050. So immediate addressing always will have this I in your 8085 microprocessor instruction set. So here HL register pair will be loaded with 2050, H as 20 and L registered as 50. And implicit addressing mode, RRC is an implicit addressing mode. This mnemonic itself tells you that the accumulator content should be rotate to the right. And register addressing, move A comma B. So here the source and destination register are A and B. So direct addressing, load the accumulator of the value which is present in the 30FF. So the memory location is given in the instruction. It is a part of an instruction. So it is called as a direct addressing. The address of the content is given directly in the instruction. How many times will the loop will be executed? So they have given the code. So XRAA MVI C comma 05. So this 05 C acts as a counter. No, C is given as 05. So first I will be decrementing the C register to 04. So since it is not equal to 0, the loop is executed for once. Then 4 will be decremented as 3. Then it is not equal to 0. It's so second time it executed. So it goes for the loop. Then from 3 to 1. Then 1 to 0. So what happens? 5 times the loop will be executed. The 5th time it will be aborted as the C value becomes 0. So it has been executed once. So totally it will be executed for 5 times. So if a microprocessor uses 5 megahertz clock, the duration of one T state is T equal to 1 by F. So the duration of one T state is going to be 0.2 microsecond. What is the status of 0 flag and the content of accumulator after the execution of the following assembly code? So MVI A is equal to 65. So A value is going to be 65. MVI B register B is equal to 32. So B value is 32. They ask you to compare. So comparison is nothing but done by A minus B. Only the status flag will be affected. The content of your accumulator will not be affected. So A minus B if I perform, then what happens, the output should be is 33. So here the content of your accumulator will be same 65, but the status flag alone will be changed here. So here the 0 flag, so we are worried about only the 0 flag and the accumulator. So since the A minus B output is going to be 33, so it is a non-zero value, so 0 flag will be reset. Suppose if your subtracted value is going to be 0, then the 0 flag will be set. For this case, the 0 flag is 0 and accumulator content will be, it will be retained, that 65 will be retained. So the net result will not be affected, only the subtraction is done only to update the status flag, not the accumulator content. How many bytes does the following sets of instructions occupy? So here MVI A comma 35. So for MVI A 1 byte, and for this data it is going to be another byte. So it is going to be 2 byte for this one. Then similarly MVI B comma 23. MVI B for mnemonic 1 byte, the data which is given here is 23, so it is going to be 2 bytes. Suppose instead of this 8 bit, if there is 16 bit, that is if they are going to give address, then it is going to be 3 byte data, or if it is LXI H comma 2050, so 2050 is going to be 16 bit, so it is going to be 3 bytes. So here it is 8 now, so it is going to be 2 byte. For ADDB, for mnemonics alone, it is going to be 1 byte, so totally it is going to be 5 bytes. For the 8085 ALP, the content of the accumulator after the execution of the program. So MVI A is 45 and move B comma A. Now the content of your A register will be moved to your B. STC is set carry, carry bit will be set. CMC is complement the carry bit and rotate the accumulator right to the carry. So and then prove XRA B. So exclusive OR operation is performed between A and B. So now your A value is 45 and your A value is 45, B value is also 45. Here STC is carry bit is going to be set, next CMC the carry bit will be reset. So now I am going to perform the rotate operation. The A value is 45. So it's 45 is nothing but 0 1 0 0 0 is going to be 4 and then 0 1 0 1 is going to be 5. I am going to rotate it and then the carry is going to be 0 because CMC is going to be, you are going to complemented the carry. So the 1 becomes 0, so the carry value will be 0. Now I have to perform the write operation. So write operation is I am going to move the value here, that is D7 to your D0, so D7 to D6, D6 to D5 likewise and D0 to your carry. So if I am going to perform this one, so what happens, I will be moving the values here, right. So if I am moving the values, the carry value will be moved to this, the last position here. So this is how it will be changed and then I will be performing the accumulator value will be 0 0 1 0, the value is 2 now and then 0 0 1 0, the value is going to be 2 now. So the accumulator content is 22 and I am going to perform the exclusive OR operation with your B content, that is 45. So 0 0 1 1 1 0 0 0 1 0, B value is 45. So 0 1 0 0 0 1 0 1. So here I am performing the exclusive OR operation. If any one of your value is going to be 1, I am just going to, the output is 1, else the value is 0 here. So the exclusive, after performing exclusive OR operation, the content of your accumulator will be 6 7. So in 8085 microprocessor, addressing mode of CPM M is indirect addressing mode. So if the register, if any one of the register of your instruction is M, then it is default, the addressing mode is going to be indirect addressing mode. So between DCR and DCX instruction, so DCR is decrement the particular register, DCX is register pair. So the status flags are affected by both DCR as well as DCX. Except carry flag, all other flags will get affected. So after the execution of the following instruction, determine the status flag of the register content. So So, MVI A comma BF and ADI 1 comma 1B. So, the accumulator content is BF and then the content should be added with your 1B. So, the accumulator content A is BF and then 1B is this one. So, if I perform this addition, 1 plus 1 is 0, 1 carry 1. So, 1 plus 1 plus 1 is 1 carry 1, 1 plus 1 is 0 1. So, like this I will be performing the operation. So, this is the flag register of your 8085. So, yes, sign flag, 0 flag, 0, auxiliary carry flag, parity flag and carry flag. So, if your D7 bit is going to be 1, your sign flag is going to be 1. And then if your output is going to be 0, the 0 flag is 1. So, since you have your value, the 0 flag is 0. Auxiliary carry flag, from lower nibble to upper nibble you have your carry. So, we will be saying it as a auxiliary carry flag is set. And here the for even parity, the parity bit is set, but here it is as odd number of ones, and here there is no carry, the carry is reset. So, this is your flag register content. So, the clock frequency of 8085 microprocessor is 5 megahertz. It is the time, if the time required to execute an instruction is 1.4 microseconds. So, the number of T states needed for the execution is, so execution time into your clock frequency. So, which is going to be 7. So, 7 T states. What are the states of auxiliary carry and carry flag after executing the following statement? So, H is moved to the H register, 5D is moved to 6B is moved to L register. Now, H content 5D is moved to your accumulator, that should be added with your 6B. So, now what happens, your A content is H, that is 5D. So, 0 1 0 1 1 1 0 1 and your L content is 0 1 1 0 1 0 1 1. So, if I perform the addition operation, the auxiliary carry and carry. So, here from lower nibble to upper nibble you have your carry. So, your auxiliary carry flag will be set and there is no carry after the last bit. So, your carry is going to be 0. Content of the stack pointer after executing the following instructions they have given. So, here normally content of your push operations can be performed. First, the register, the stack register is subtracted by 1, then the content of your B register will be pushed, again it will be subtracted by 1 and content of your C register will be pushed. So, totally your stack pointer will be 3FFD. So, 3FF. So, it will be decremented, then what happens, your B value will be, then it will be decremented by 1. So, it will your C content will be moved. So, SP is equal to 3FFD. So, 8085 has 2 instructions for dealing with the subroutines of call and return. So, thank you for the day. So, we will meet in the next assignments. Thank you guys.